Greedy best first search. Take a graph like showing on the screen. S is a root node and it's also called as initial state. From S to AB and A to CD. B to EF. ET then F to IG. G is a goal node. In the side of a graph we see a table. In that table, every passing nodes from root node S. They considered passing values. They represents to show like H of N. Then fulfill the values in these table from each and every passing nodes. Procedure to do solve greedy best first search. Step 1 to do open and close. From root node S open A, B close with S in square brackets. Open A and close S, B. Because in the graph the passing values are less than and greater than, in that way whenever where in that table any less than passing nodes are passing through root node S, then we have to delete that less than passing node value and keep going with another nodes in these same iterative way. Then they require to show like open A close S, B. That's it, and see total passing nodes. To write in these greedy best first search way. Time complexity T of C is equal to O of B to the power of N. Space complexity S of C is equal to O of B to the power of N. And when it's complete these procedure iterative manner, it's in optimal mode. Otherwise not in optimal mode. Greedy best first search in the context of artificial intelligence. Greedy best first search is an informed search algorithm that selects the path that appears to be the best based solely on heuristic information. It's often used in situations where the search space is too large for exhaustive search methods. Efficiency. Greedy best first search can be very efficient in finding a solution when the heuristic function provides accurate estimates of the distance to the goal. It often explores paths that seem promising, leading to quick solutions. In some cases, memory usage, it requires less memory compared to other search algorithms like A*, because it only needs to store the open list, which typically contains fewer nodes. Certainly, here are some disadvantages of greedy best first search. 1. Lack of optimality. Since greedy best first search selects the most promising path based solely on heuristic information without considering the actual cost of reaching the goal, it may not always find the optimal solution. The algorithm can get trapped in local optima and fail to explore other paths that may lead to a better solution. 2. Incomplete. Greedy best first search may not find a solution even if one exists. This can happen if the heuristic function is overly optimistic and leads the algorithm away from the goal, or if there are obstacles that prevent reaching the goal state. 3. Heuristic dependency. The effectiveness of greedy best first search heavily depends on the quality of the heuristic function. If the heuristic function does not accurately estimate the distance to the goal, the algorithm may make poor decisions, leading to suboptimal or failed solutions. 4. Memory usage. Although greedy best first search typically requires less memory compared to other search algorithms like A*, it can still consume a significant amount of memory, especially in scenarios with a large search space or when the heuristic function leads to the exploration of many nodes. 5. Not suitable for all problems. Greedy best first search is most suitable for problems where finding a feasible solution quickly is more important than finding the optimal solution. For problems where optimality is crucial, greedy best first search may not be the bestly exploiting the most rewarding actions as more information is gathered.